Come on, welcome back. Dive into C. Dive into C. Hey, backbenchers, I'm calling you. Dive into C. Come forward. Come forward. This course is for you. This course is for you. You are not the coward. You are not the insect. You are the tiger behind me. Look at the picture. You are the tiger. You are the tiger behind me. So jump. Jump. Let us learn C. Let us say to the world, we are great. Show thumbs up. Come. This course is for you, backbenchers. So structure of a C program. Structure of a C program. Every C program consists of one or more modules. Every C program consists of one or more modules called functions. One of the functions must be called main. The program will always begin by executing the main function, which may access other functions. So every C program is made of what are called as modules. What are called as modules. In case of C language, they are called as functions. In case of C language, they are called as functions. In case of C language, they are called as functions. There is one function called as main function, where the program execution starts. So if you take a C program, that C program definitely consists of main function. So program execution starts at that main function, and then depending on your requirement, you can add one or more other functions also. It depends on your requirement and your wish. So, but C program consists of one mandatory function called as main, and program execution starts at the main function only. So each function must contain heading, which consists of basically the function name, followed by an optional list of arguments enclosed in parentheses. Function name. Function heading consists of the function name. Okay. Function name will be there. So main is also one function name. So every function consists of a function name followed by optional list of arguments. So if it is a main, so they are enclosed in the optional list of arguments are enclosed in parentheses. So these are the parentheses. Parentheses means these symbols. Okay. There are other kinds of symbols like square brackets, flower brackets, etc. But this refers to the parentheses. So every function starts with some function name. The mandatory function is main. Apart from it, there can be other functions also. So program execution starts at this main function, and within the parentheses, if you want, you can supply the parameters. You can supply what are called as parameters or arguments. What exactly is the difference between those things, we'll study later. But you can say that for the time being, you can say that within the parentheses, you can write some arguments, some names. So A, comma B, something like that. Okay. Next, this will be followed by the bracketing symbols. These are the bracketing symbols, flower brackets. So these are the flower brackets which indicate the beginning and end of the function. If we have multiple functions, they will be separated. So this main has this beginning of the function and end of the function. That means main related code is present within these flower brackets. Of course, there can be nesting for these flower brackets also, that we'll see. But every program or every function in particular starts with this opening flower bracket and ends with the closing flower bracket. So within these flower brackets, you can have optional list of declarations. Sometimes declarations may not be necessary also, but declarative statements should be present here. Declarative statements should be present here. Declarative statements, they should be present here. Okay, usually at the beginning. In some compilers you can declare when as and when required, but it's better you declare everything after this opening flower bracket, declarative statements. So the other kind of statements are executable statements. Executable statements. Executable statements. So this is the basic format of the C function. This is the basic format of the C function. Main here is the function name. Main here is the function name. So which is actually a mandatory function. If you want other functions, say that case you can have the function one like this. You can write if you want. Okay. Main function, declarative statements will be there, executable statements will be there. Declarations or declarative statements provide information. What information we will see, and executable statements will have some effect. Will have some effect. What kind of effect, that also we will see. So this is the general structure of a C program. So you can see the general syntax. General syntax of a C program. General syntax of a C program. Pre-processor directives will be there. We discussed about these main declarations, etc. But apart from it, there will be what are called as pre-processor directives. Pre-processor directives. Pre-processor. What do you mean by pre-processor? So here processor in the sense that compiler. Processor means compiler, not the hardware processor actually. So processor refers to the compiler. So that means before doing something, you have to do something else. Before doing compilation, you have to execute these pre-processor directives. So pre-processor directives. So here processing refers to compilation. There are certain things to be done before compilation. Those things are represented in the form of directives, which can be considered as the instructions to be followed. They provide some information. They ask you to do something. What are those pre-processor directives? Those things also we'll discuss. But this is the general syntax. Pre-processor directives, main, opening and closing flower brackets. Within that, you have some declarations of variables followed by executable statements. So a preprocessor is a software that can be considered as part of the compiler or a separate module that is invoked by the compiler. It's a technical issue. You need not understand it. But if you want to design a compiler for a particular language, then you should think whether the pre-processing should be done as part of the compilation process, or whether this module should be a part of the compiler, or whether it should be separate one. But anyhow, as a programmer, you need not bother too much about it. The preprocessor is a software that can be considered as part of the compiler as a separate module invoked by the compiler. Now, what are the preprocessor directives? They can be classified into three types. Hash include is one. Hash include, hash define, and then conditional compilation. These are the three types of preprocessor directives. Among these, maybe at the first year level, you usually don't use this conditional compilation directives. So we'll be using this hash include and hash define, and always we use a hash include. Hash define, depending on your requirement, you will be using. Hash include is a directive asking the preprocessor to include the contents of the header files. So what it is saying, as the name indicates, include. Include means include something. What you have to include? Include the contents of what is called as header file. So what is that header file again? header file. Why we should include it? We'll see. Header files contain declarations of the programming constructs of the C language, which are necessary to execute the programs which have included that file. So that means these .h files contain some declarations. So declarations means what declarations? What declarations? So those declarations helps your program in getting executed. So we'll go to the next slide for clarity. There. So to be more precise, the C program which we write is only small part of the software required to execute a program. So we discussed it previously also. You cannot write the total program in the sense that you cannot do all the tasks. Suppose you want to capture the information from the keyboard. You want to know which key user has typed. Not a simple task. You require a lot of things to be done. So the software which does is actually called as device driver. And again the device drivers, that is a software that is available, but you cannot invoke it directly. So whenever you want to use the keyboard, or whenever you want to find out what key is pressed, you have to actually capture the position of that key. So that is done by the device driver, but because you cannot again use the device driver directly, there will be what is called as some code, some library code, something similar to your library books. There will be what is called as library code, which invokes the device driver, finds the key that is typed by the user and gives it to your program, and gives it to the user program, to your program. Okay. So C program which you are going to write is only small part of the software. So you have program, your program, say your program makes use of what are called as library functions, libraries. Okay, libraries. Again, these libraries actually consists of two things. So one is .h files, which basically contain declarations, and .lib files, which contain the code, which contain the actual code. You can see a declaration. Declaration means you just make a statement, you announce something like announcing. But actual code is present in .lib files. But .lib files, if we consider that .lib files, so there will be a lot of code in it. You cannot include that one. So what is required according to C is you need to include only .h files. We'll see one .h file also. So .h file has to be included. What does it mean? So when you include .h file, so what exactly happens is the contents of the .h file, are added to the program, are added to your program. The contents of .h file are added to your program wherever that hash include statement is there. So at that point, the declarations that are present in that .h file are added. So next preprocessor directive is hash define, is for what is called as macro substitution. Macro substitution. Macro substitution. Okay. Hash define. What do you mean by substitution? What do you mean by substitution? Why substitute? It means you are using something and that has to be replaced by something. Substituted. What is it? So for the time being, I'll just give a simple example. So we'll make use of this pi. So suppose you are writing programs related to mathematics, calculating the areas, parameters, etc. Pi r square, 2 pi r, etc., etc. So now suppose you are calculating the areas, parameters of several geometric figures, and all the formulas consist of this pi. All the formulas consist of this pi. So instead of writing say 3.142, instead of writing 3.142, so what you can do is, you have to write the 3.142 at every point. What you can do is, you can do like this: hash define pi 3.142, pi 3.142, hash define 3.142. So that means if you write like this, wherever pi is available, you can just write it as pi. We can't use these mathematical symbols in programming. So that point you remember. You cannot type that pi. Even if you are able to somehow search and identify it and type it, you will get an error message. Okay, that is not part of the C character set. That is not part of the C character set. So what you can do is, you can write like this, and wherever pi is there, you can write pi. Okay, there is one advantage here. May not be with respect to this pi value. Suppose there is something like x which has 10, and again x value is used at different points in your program. So then what you can do, wherever x is there, you can write 10. Now suppose that value of that x you want to change. Now you want to make it 20. So what you have to do, if you want to make it 20, you go to each and every point where you have written the value of x as 10, and you have to replace it with 20. So, but if you declare like this, hash define x 10, then you can write at every point x. Now if you want to change it to 20, what you can do, you can just change it here, hash define x 20. That's all. Okay. So that is the advantage. We will discuss extensively this hash define later. There are some directives which can help in conditional compilation. So if something is defined, do something, compile this thing, otherwise don't compile. Like that, you can do many things, but this is beyond our scope. So every C program consists of collection of modules. The mandatory module is main. The programming constructs like variables, functions, etc. are to be declared to provide information to the compiler. So the declarations are present in declarative statements. Where declarations means you will be declaring what are called as variables, functions, etc. And the main logic of the program is present in executable statements. So these flower brackets are used as bracketing symbols. So whatever the statements which you enclose in these flower brackets, they are called as block of statements. So declarative statements provide some information only. Executable statements will have an impact. What is that impact? You achieve the main thing using these executable statements. What is the impact? So impact is you will be assigning a value to a variable. You will be performing some arithmetic operation, reading and printing of some value. Performing some arithmetic operation means, say if 10 and 20 are there, you can just add 10 plus 20. So it will have an effect. What is that effect, or what is that impact? We will get the sum of 10 plus 20, that is 30. So that is the impact. That is the impact here. So x equal to 10 means, that means x variable or location whose name is x will get stored that 10 value. So like that, it will have some impact. The declarations provide information. They are also required. So you should provide correct information. Otherwise, your program will not execute. But the main logic will be in executable statements. Okay. The first C program. Just have a glimpse at it. Read each and every statement. So as you can see, so this one, what is it? This is pre-processor directive. This is the pre-processor directive. So followed by mandatory function main, and then this opening and closing flower brackets. Okay. Opening and closing flower brackets. This is opening bracket and this is the closing flower bracket. So you can see these are the declarations. What we are declaring? We are declaring A, B, C as integers. Now what exactly is the integer? Why we have to declare like that? We will see. But what we are doing here, we are declaring A, B, C as integers. Declaration should be provided. Okay. Next, what we are doing, these are the executable statements. All these three are executable statements. Executable statements. Okay, executable statements. All these three are executable statements. All these three are executable statements. So A equal to 10. That means A is getting the value of 10. What exactly happens is, before I show that memory, let us complete this one. A equal to 10. That means A gets the value of 10. You can say 10 is named as A and B gets the value of 20. So now A contains 10, B contains 20. What we are doing? C equal to A plus B. That means the contents of A and B are added. That means what is the value of C? A plus B, 10 plus 20, that is 30. After that printf statement, you are printing the value of C, which is 30. So 30 will be printed. Okay. So these three complicated. Diagram, time consume. Very simplified version. So if you consider this as a memory where each location, say, is capable of storing 1 byte or a word of information, whatever it be. So A equal to 10 means, say if this is A, some location will be labeled as A. And when you assign the value of 10 to this one, that means, so 10 will be stored here. Similarly, B, suppose if this is the B, suppose this is the B, and B equal to 20 means, B equal to 20 means 20 is stored here, 20 is stored here, and C equal to A plus B. So C again will be referring to some other location. So this is C. And what is the value of C? 30. So 30 will be stored here. This is what actually happens inside the computer memory. Inside the computer memory. And printf means you are printing it. Printing it where it is printed. Again, there will be different devices where it can be printed. Okay. It is displayed, generally it is displayed on the screen or display. So on the screen 20 will be printed. On the screen 20 will be 30 will be printed. The value of C, 30 will be printed. Okay, this is the first C program. Just try to recollect what we discussed. Take 1 minute time. So preprocessor directives followed by the main mandatory function, followed by the opening flower bracket, followed by the declarations, followed by the executable statements, followed by the closing flower bracket. So general syntax, we discussed the general syntax. Please remember it. General syntax. Initially, better you note down that general syntax and follow it. So hash include stdio.h is a preprocessor directive asking the preprocessor to include the contents of stdio.h file where this statement is present. So the contents of stdio.h replace the statement hash include stdio.h. That means here is the stdio.h statement, hash include stdio.h. So whatever the contents of this file stdio.h will get substituted here. So it may that file may contain 10 statements, 20 statements, whatever may be the case. So this statement will be replaced by stdio.h statement will be replaced by the contents of stdio.h okay. So the contents of stdio.h will replace this statement. stdio.h contents get replaced. So flower brackets again which indicates the beginning and end, and integer ABC, they are the declarations which indicate that ABC are integers. So that means int stands for integer. Note that statement is terminated by semicolon. So semicolon in case of C language is called as statement terminator. Statement terminator. Here you can see all these statements. So all these are terminated by semicolon. So semicolon is statement terminator, except in case of few statements like preprocessor directives, main, there will be semicolon. Sometimes for loops, in case of loops, may avoid semicolon. You may use it also whenever you want to make what is called as infinite loop. We'll see. So A equal to 10, B equal to 20, they are called as assignment statements because you are assigning the value of 10 to A, 20 to B. They are called as assignment statements. So whenever you want to assign a value to something else, you have to use equal to. Here equal to stands for assignment. Assignment. C equal to A plus B means add the contents of A and B and then store it in C. Add the contents of A and B and then store it in C. And then store it in C. Printf, it is used for printing the contents on the screen. So what is the syntax? We'll see. Printf is for printing. Why we have to use this format? What is the general syntax of again this printf? We'll see later. For the time being, just remember printf is for printing something on the screen. So as I already told you, the contents of stdio.h will get substituted for that hash include preprocessor directive, stdio.h preprocessor directive. So this is the content, sample content. You need not understand it. I have only gathered it to provide you that information regarding what is the content that will be actually present. Understanding completely the content is beyond our scope. Okay, but this is the sample content. We will discuss some of these things later modules and we will understand certain things. You can see certain things. You can see hash define is there. It is defined as 0. It is defined as 1. I can see those things. Similarly, here also some flag bits, they are defined like this. You can see these are the declarations. Some of the declarations of, we can say, variables. Declarations of variables, and then here you can see these are conditional compilations statements. Defined, if not defined, like this, all are present. And here you can see something different. Here you can see printf present here, printf which I have used. So the declaration is like this. What is the meaning of it? Why we had to write like this? That we'll study. But why we have to include stdio.h? Because we are making use of printf. Printf is declared in stdio.h. That's why we are including that stdio.h header file. Hash include stdio.h because this printf is present in that header file. stdio.h stands for standard input output. Standard input output. So there will be two kinds of input output: standard input output and file input output. Standard input output, file input output. We'll study file input output later, but stdio.h stands for standard input output header file. So these are some of the standard header files. I'm just providing you the information. We are not going into the details of these header files. So because we'll be writing simple programs. So simple programs, we may make use of these header files. stdio.h we already discussed. you are making use of this printf, scanf, etc. You have to ignore this one. Whenever you are working on strings, whenever you are working on numbers, sorry, names, addresses, etc., you want to manipulate those things, then you have to deal with this string.h. And if you are writing programs related to mathematics, you are making use of exponentiation, square root, etc., then you have to include this math.h. Screen related functions, whenever you want to clear the screen, etc., you have to use this conio.h. These are the simple header files which make use of. There are other header files also. Conversion from .c file to .exe file. Now what exactly happens? Okay, you have typed your program. So what? What happens? So typed your program. So what happens? How do you run it? How the computer actually runs it? How do you make the computer run it? There is no magic. Remember, here there is no magic. Don't expect any magic here. Everything is a lot of effort. You may put the effort, or somebody else might have put the effort, but everything involves a lot of hard work, a lot of intelligence. So whenever you type a program, that program is called as source program. The program written in any programming language, including C, that will be called as source program. Now computer understands, we discussed it previously, computer understands only what is called as machine code, its own code, or it only understands ones and zeros. Now you are writing in a source program in a C language, and we are saying that it understands only ones and zeros. That means we have to convert it. We have to convert it from source program to machine language program. For that we require what is called as compiler. We require what is called as compiler. Okay. So what are the steps involved in it? So you can see here. So the program written in C language is called as source file and is stored in filename.csc, filename.c. Whatever may be the file name that you give, you can give it. So how to give the file name? It depends on the editor that we'll see. Filename.c. So your program is stored in the form of, say, filename.c. Now hash include, etc. After doing all those things, after pre-processing, you get what is called as filename.i. Get what is called as filename.i. Filename.i. That means hash include preprocessor directives are processed. After that, we get what is called as filename.i. Now the compilation will be continue. After pre-processing, compilation will start, and the output of this compilation process is filename.obj. Filename.obj. OBJ stands for object file. OBJ stands for object or object file. Filename.obj. So it is converted into filename.obj. Now this .obj files will be linked and will become filename.exe. Now what do you mean by linking? Linking means your program .obj file is generated, but you are making use of library functions, etc., or the same program, the program which you are writing, whenever it is large, it may spread over multiple files also. In that case, there will be separate .obj files, but there will be invocation related statements within your say the program. So different .obj files which are related are linked, and which will result in what is called as filename.exe. Filename.exe. Linking may be done statically or dynamically. It's a different issue. But filename.exe. This filename.exe is one which can be executed. So the point to be noted here is you have these different programs different applications which you download in the system, they are actually .exe files. So whenever you download some software, it will be in the form of .exe only. .exe. So .exe it can be easily run. You can run that program easily. So they are the steps. They are the steps. Again, this is information for you. This is information for you. You need not do any research into this one. So file name.c will be there. After pre-processing, you get file name.i, and the compiler will act on it. And after when compiler acts on it, you will get what is called as file name.obj. Many such file name.objs will be combined if necessary. Otherwise, if it is sufficient on itself, it's okay. In that case, file name.obj will be there, and it will be directly converted into file name.exe, which will be the executable file which will execute on your computer. Okay, this is regarding the first C program. Okay, wish you good luck. Let me try to go to the compiler. Try to run it. Try compiler is available on. Okay, so this sample program is already available. Which I typed previously. If you want to see it being done, let me do it. You can delete everything and do it from the beginning. This is the most beautiful part of the C programming. You can see it live. I will be typing the programs. Maybe 70% of our rest of the time will be spending on the program. Okay, I will be typing the programs. I have done all the related programs. I have stored it in files. I can just copy and paste, just deliver the lecture and escape. But I'm not going to do it. I will type the program for you. Let's see. So what is it? First one is pre-processor directives. Here I will try to include stdio.h. So remember, sometimes I may commit mistakes. I'm human. Sometimes I may do it intentionally, so that we can understand a better manner. So during this Corona period, the best feedback I got is this online teaching is better with respect to this programming. So we are able to see the program being typed, being executed, being intentionally made modifications, and everything they are able to see it live. So preprocessor directive hash include stdio.h main. So opening flower bracket and say declarations. Okay. Next, some a equal to some 20, say b equal to 30, say c equal to a plus b. We are doing it. Let's say printf %d c. Okay. Okay. So like this. Let us try to execute this program, and find out whether I get any error or not. So if you are not aware of this environment, just have a look at it. How to explain this Turbo C environment. We'll be using different programming environments because some of you may be using the cell phone, some of you may be having the systems. So we'll be using different things. But for the time being, just have a look at it. Just have a look at it. But note that the program will be same. Whether you use mobile phones, whether you use Turbo C IDE or some other IDE, okay, doesn't matter. Doesn't matter. The program will be same. Okay. Let me try to compile it. Okay. So no errors. It is saying no errors. The warnings, it's okay. You can neglect that those things. Warning function return a value. Okay. Warnings you can neglect. Otherwise, you can return a value also. That we'll see later. So next, I will try to execute Control F9. This case. Now what happened? Okay, I have calculated it. I try to run it. Want I can run it again. Okay, here also that is available, but will be most of the time we'll be using the keyboard shortcuts. So run it. The program run, but I cannot see anything. What is happening? I cannot see anything. What is happening? So let me show the output. So 50 is printed twice because I have executed it twice. Output is coming, but why I am not able to see it? That means system is not waiting for you. System is printing. It's doing its duty, but it's not waiting for you. You are very slow when compared to a computer. That's why you are not able to see it. So, and whenever we are seeing the output, we don't want to again see the previous output also. It becomes cumbersome. So what we do, so we should be able to clear the screen. So what is the header file? What is the header file related to it? Screen related functionality. Recollect is hash include conio.h, hash include conio.h. Okay, what is the functionality that we are going to make use of? CLR SCR. This is for clearing the screen. And the other one which we make use of is what is called as get, which makes the system wait for you. Now let us run it. Save it and then actually you have to compile it. Okay, but again, so you have to go here. You can use the mouse and click this one. I am using keyboard for it. So compile. So Alt plus F9 is the key combination. So we usually will be using the key combination. So compile. Okay, problem. Okay, next I'll be executing it. Now you can see here 50 is printed and it is waiting for you. So if you press any key, it will exit. If you press any key, it will exit. Until you press any key, it will wait for you. So that is the functionality that is provided by, Getch. That is the functionality that is provided by Getch. The clear CLR SCR clears the screen. Getch will wait for you to press any key. Okay, this is the program. You can play with it. Say, let us remove this one. Now I will try to compile again. Alt F9. Okay. So what is happening? It is showing one error. A statement missing semicolon, statement missing semicolon, statement missing semicolon. Which statement? So this statement should have semicolon. So please note that compiler is written by highly intelligent people. Okay. Please follow the compiler generated error messages for correcting the errors. So often we overlook the error messages that are generated, get anxious and fail to execute the programs. So always follow the compiler instructions, compiler error messages. It generates the error message in a perfect manner. So here semicolon is required. Now you can try it. So it is executed and you can see the output. Okay. So like this. So you can create many kind of errors, but for the time being, this is enough. Okay. So we will exit from here.